Okay, let's look a little bit more at expressions. I know this is like the 4th time, but the more we understand about it, the better we'll be. Okay, so let's look at the following expressions. 6x squared. We haven't really had expressions that are more intricate like this. We usually have 3x, 4y, but this is a little bit different. So number 2, negative 3xy, xy cubed, and 4, negative x cubed y. Okay, we want to write these in factored form. So let's think about what this really means. I want to make a big deal about the exponent here. Remember, the exponent only works on what's to its immediate left, so what it would fall on. If that 2 falls, it's going to fall on the x. So this is actually 6 times x times x. Okay, here, obviously it's a little simpler because we have no exponent. This is all attached by multiplication, so we have negative 3 times x times y. Here, be careful, because the cube would only fall on the y. It has nothing to do with that x. Okay? So this is x times y times y times y, because there are 3 of them. So y cubed, just like 2 cubed, would mean y, this 3 times, because the 3 tells me use y as a factor 3 times. As a factor means attached by multiplication. Okay, here, now I want to write what number would be there, because technically the x is not what we're saying it's negative. There's actually a number there you don't see, and it's a negative 1. So this is really negative 1 times x times x times x times y. That 3 only is working on that x. So it's x times x times x times y. Okay, so every single term has a number factor. This is one term, and if you remember why, it's because terms are attached by plus or minus. There's no plus or minus in here. So this is one term, this is one term, this is one term, this is one term, because there's no plus or minus there. Okay, now we're going to look at this one a little bit more closely and talk about the numerical factor and the variable factor. Again, just to kind of make sure you understand this. 6x squared. I'm going to leave this up because I think I'm going to go back and talk about that here as well. Okay, remember the number factor, which here is 6, that is called the numerical coefficient or the coefficient. The variable part, or the variable factor, is actually called that, the variable factor. Okay? And we already said that terms that have the same variable factor are like terms. Let's take a look at these 3 now, 2, 3, and 4, and talk about the coefficient and the variable factor. Okay? So let me use the same color. So we already talked about that one. Okay. Let's talk about these first, and then we'll talk about some other examples. Okay. So the coefficient here, the variable factor. The coefficient here is negative 3. The variable factor is xy. It's the variable part. Okay, the coefficient here is 1. The variable factor is xy cubed. Here, the coefficient is negative 1. The variable factor is x cubed y. Now there's a chart in your notes, if you would do that, and then we'll look at the answers. Okay, let's take a look at what you did. So the coefficient here is negative 3. The variable factor is everything else, which is the x, y. The coefficient here that you don't see is a 1. The variable factor is x cubed y squared. The coefficient here is 7. The variable factor is a squared bc. The coefficient here that you don't see is a negative 1, because I have to put a 1 there. The variable factor is x cubed y z to the 4th. And again, when you have the same variable factor, you have like terms. So none of these are like terms because none of these match in variable factors. Okay, there's a problem on the bottom of that workbook page that tells you to separate the like terms together. So if you do that. Okay, we have 2x squared, comma, negative 3x, 4x cubed, negative x squared. And the second one is negative x squared y, 2x y squared, x squared y squared, squared y squared, 3xy squared, 3xy squared. This is a crazy one. Negative 2x squared y. Just in case you want to not be confused, don't look at number 2. Okay, let's take a look at this. We're looking at the variable factors. So if you want to be friends with 2x squared, you have to have an x squared. Okay, so 2x squared has a friend right here, negative x squared. We're not combining, we're just grouping. So those are like terms. Negative 3x, let's see if he has a friend. Negative 3x, we just need another variable factor that's an x. And that's right there, negative x. And then the only one that's left out in the cold is 4x cubed, no like terms. No friends for 4x cubed, sorry about that. So those are separated into like terms. Okay, let's take a look at this one. This one's a lot harder to look at this. This is x squared y. The only thing being squared here is the x. So let's see if the negative x squared y has any friends. If it has any friends, it's got to be an x squared y. This isn't the same, that's xy squared. This isn't the same, they're both squared. Here's an xy squared, so that's okay. So we got a 3x, oops, sorry, that's not the same. That's the y is squared there. Here we're okay. Negative 2x squared y. So those are friends, so they're good. Now let's look at this, 2xy squared. And just in case you're not sure, that is one expression because it's one term because there's no plus or minus. So that's why it's one term, because there's no plus or minus. Let's see if he's got any friends. 2xy squared. There we go, 2xy squared. Is friends with 3xy squared because the x is to the first power, the y is to the second power. The coefficients do not have to match. And then, of course, we got this lonely guy, x squared, y squared. And he can't even be friends with him because he's not his like terms. So that's like terms, same variable factor. Okay. Let's readdress this evaluate ordeal that we've been dealing with. So let's evaluate the following when x is 3. Okay, let's look at x is 3 for these two expressions. I'll put them side by side so we can compare them. I'll let you do the first one, and then we'll do the second one together. Okay, and x is 3. All right, here we go. X is 3. Remember to use parentheses because we're substituting. 3 plus 10 is 13. That was easy. Okay. It's that button on that commercial. Anyway. All right, let's look at this. 2 parentheses for the x plus 30 minus parentheses for the x minus 20. In the parentheses should go to 3. So now order of operations. Okay, now here we go, backing up to order of operations. Parentheses, nope, these are not parentheses because there's no operation inside. Exponents, no exponents. Multiplication, yes, there's a multiplication. So this is 6, and I've multiplied, I can take the parentheses off. Plus 30, this is just minus 3, minus 20. Now we're going to go left to right. Wow, that's a good marker, look how dark that is. Okay, now we're going to go left to right. 6 plus 30 is 36, minus 3, minus 20. Now, either 36 minus 3 or back to I have 36, I owe you 3, so I have 33. I have 33, but I owe you 20, so I have 13. Notice that these have exactly the same answers. That means this is equivalent or equal to this. Let's see why. Take a look at this for a second. I'm going to erase this, the answer that we just did, all the work we just did. What a thrill for you. And all the work we just did here. And I'm going to show you something. All right, so let's take a look at this. All we know now is that when x is 3, this expression is equal to this expression, but I wonder if it's true for all real numbers. Here's how we can check. Notice that I can combine like terms here. 2x has a friend, it's this negative x. So if you want to do this off to the side, I don't want to move that. It's for a reason I don't want to move that. There are no sides like there were in equation solving. I don't want you to get used to moving things. I'm afraid you're going to change signs. So I have 2x minus 1x. I can write that x as 1x. So I have 2 x's, I owe you 1x, so I have x. That's what that is. And then I have 30 minus 20. So I have 30, I owe you 20, so I have 10. So that's x plus 10. Notice this is exactly the same as this. So now we know this expression is not only equal to each other when x is 3, it's equal no matter what the number is, because these two are equal. I've simplified that to show that. So here's all we have to do, remember, to combine like terms. To combine like terms, first we look for like terms when we're combining. Then we combine the coefficient. I have 2, I owe 1. So I have 1, keep the like term. So that's what we're doing. We're looking for like terms, combining coefficients, keeping like terms, and that's how we do that. Okay, take a look at this. You have to really understand like terms in a question like this. This one says, is 3xy equal to 3yx? Take a minute to think about that. Think about what you know that might help you answer that question. Well, there's 3 factors here. There's 3 factors here. And all we did was change the order of which we multiplied them. That has to be true because of the commutative property. Okay? And remember, whenever you have more than 2 factors, multiply any 2 first, then the answer by your third. That's all true because of the commutative property. I can prove to you that's true. I can prove to you it's true by, yes, using a number. If x is 5 and y is negative 2, I can prove to you that this is true. Because if it's true, the left side of the equal will look just like the right side. So let's try that. So we have 3xy equals 3yx. So x is 5, y is negative 2, x is 5. Oh, that's y, sorry. So y is negative 2, x is 5. This is 3 times 5 is 15 times negative 2. Positive times a negative, signs of difference, so it's negative 30. 3 times negative 2 is negative 6, because the signs are different, so it's negative. Times this 5. Signs are different again, so the answer is negative. 6 times 5 is 30. So this is true. So what happens if I have a problem that says this? 6xy plus 3yx. They all like terms. That tells me I can add them. The rule for addition, we said, was look for like terms. We have them. Combine the coefficients. We will. I have 6, I have 3, I have 9. Keep the like term. How should we write the like term? The truth is it doesn't matter. You can either write xy or yx. Generally, we write xy because it's alphabetical, but it does not matter. Okay? So let's look at a couple problems, and we can try to combine, if we can, like terms, or at least simplify what we can simplify. Okay, I'll do the first 2 with you, and then you can do the last 3, and then we'll check our answers. All right. So this is simplify. Remember, simplify is different from evaluate. We're not going to get a number answer. Well, unless they give us a number. I don't think they are in this problem. Wow, this is a big one. That's cool. I like the big ones. Okay, number 2. This is a little confusing sometimes, M and N's, but we can do it. Okay, let's do this one first. And again, you might want to do some of this off to the side. So we have 4x squared. Let's look for like terms. The variable factor is x squared. We got to look for another variable factor to be x squared. Here it is. No others. So you might want to do this off to the side. I have 4x squared, but I owe you 8x squared. If I have 4x squared, but I owe you 8x squared, Then I owe you 4x squared. So that takes care of that. Now I'm going to go just to the next term, see what happens. Negative 3x. See if they have a like term. They do right here, because our variable factor is x. That's, I've already done that. I'll cross it out. That's negative 3x minus 4x. I owe 3x. I owe 4x. So I owe 7x. I owe 7x. Oh, that looks bad. That looks like a mustache on that 7 or something. Okay. That's negative 7x. Remember to put the sign there, right between them. So that takes care of that. And then all you have left is this positive 9 and positive 1. I have 9, I have 1, so I have 10. So you can do the work off to the side. Be really careful. It does get a little messy. Okay. All right. And that's it. I'm done. I cannot combine these because these are not like terms. X squared is not the same as x. Okay, it's not the same variable factor. Let's look at this one. All right, 3mn. You need mn. Well, this is nm. Is nm the same as mn? Yes, it is, because it's the commutative property. And this is an mn, so they're all like terms. So I have 3, but I owe you 5, so I owe you 2. mn, I'm going alphabetical, plus 7mn. I owe you 2mn. That's even hard to say. I owe you 2mn. I have 7mn, so I have 5mn. And that's it. So you try 3 through 5, and we'll check it out. All right, let's see how you did. Let's take a, of course, I gave the hard one again. 8a cubed minus 2a squared. I look for friends for 8a cubed, and I don't find any, because the literal, because it's sometimes called the literal factor, but we're calling it the variable factor, same thing. The variable factor is a cubed. We don't have another variable factor as a cubed, so it doesn't have any friends. Equally, this doesn't have any friends, because here the variable factor is a squared, and we don't have another a squared. So this you cannot combine, and that's the answer, can't combine. Okay. Here, let's take a look. We're looking for the same variable factor. AB is the variable factor, and there's his friend, AB. I owe you 10, but I have 10, so I have 0 ABs, which is just plain 0. Opposites, sum is 0. Okay, the hard one. Ready? 7x squared y. 7x squared y. That's one term. 7x squared y. We need another x squared y. Here he is. This is the other x squared y. So we have 7x squared y minus x squared y. If you want, you could put the 1 there. So I have 7, but I owe you 1. So I have 6x squared y. That's what happens when you combine that. Okay, I'm going to erase that so we don't get it in the way. Now let's take a look at the 2 in the middle here. They are the same variable factor. X to the first power, y to the second power. Because remember, if you don't see an exponent, the exponent that's there is a 1. Okay, so I can combine those. I owe you 2, I owe you 4, so I owe you 6. Keep the like term. Okay? All right. So far, I hope that's good. Let's take a look at this next one. Let's, again, try to use something we already know to try to teach us something we don't know. So look at the following. 2 times the quantity 8a. There's actually 3 factors here. The 3 factors are the 2, the 8, and the a, because that's actually 2 times 8 times a. However, what I could talk about this being is there's 2 8a's. So this really means 8a plus 8a, which we now know they are the same variable factor, 16a. So I wonder if there's a shortcut for this. You may already have seen it. Notice that if I just go 2 times 8, I'd get 16a. 2 times 8 is 16, 16a. So all you have to do is multiply the 2 numbers together. Now, this is really important because some people want to distribute this 2. They want to take the 2, distribute it to the 8, and distribute it to the a. We can't do that. Do you know why we can't do that? I'll tell you. We can't do that because there are no terms inside here. Remember, we can only distribute across terms, so there are no terms. There's no plus or minus. So that's why we can't do that. So when there's all factors, all you do is straight multiplication, numbers with numbers, and the letter just comes back for the letter just comes with us for the fun. Okay, so let's take a look at how that helps us do these problems. Okay. I want to keep that on the board so you can see that example. Negative 5 times 3x squared y. Let's do that first. Again, in here are just factors. So I'm not distributing, I'm just straight multiplying. So all I do is multiply the numbers. Negative 5 times 3 is negative 15. X squared y. Done. That's pretty cool. That's easy, straightforward. Let's try two more. So make sure you know what you have inside your parentheses, if you have multiplication or if you have terms, because it matters. Okay? 20 times negative 2y. Oh, that's terrible. Okay. That looks equally terrible, but okay. Oops. Number 3. It's always good to write backwards. Okay. Number 3 says negative 10 times negative b. Let's talk about that. Negative 10 times negative b. All right, here we go. Again, we have factors in here, so we can't distribute. We're just doing straight multiplication. This is a positive times a negative. Signs are different. In multiplication, when the signs are different, you get a negative. So this is negative 40y. Here, notice what we did in every problem. We multiplied the numbers. Well, we have to talk about what the coefficient is here. The coefficient here is a negative 1. You might want to put it in. So the signs are the same. We get a positive. 10 times 1 is 10. So we get 10b. So the answer here is 10b. The answer here is negative 40y. Let's take a look at this next question. We want to know if this is true or false. Okay, true or false? 5 times the quantity 3 plus 4 equals 5 times 3 plus 5 times 4. Do you think you'll get the same answer if you do this side as if you do this side? If you think about it, this is something we really already talked about. Okay? Here, really, you should be using order of operations. And here, you have to do order of operations as well. Watch what happens, and then you could think about why this happens. So we're going to do this side first, parentheses first, we get 35. Here, we get multiplication before addition, 15 plus 20, and that also is 35. Now think about why that's true. What did we really do? If you think about it, what we really did was what we were just talking about. We distributed. We said there are terms in here, so we'll go 5 times 3 plus 5 times 4. So this is the distributive property. We're just reminding you of when you use it. You use it when there's multiplication outside and terms plus or minus inside. Okay, that's when you use it. So you need two things, at least two operations when you have distributive property. You need multiplication over terms. And there could be as many terms as you want in here, but it's got to be multiplication over terms. So there's got to be a plus or minus inside and a multiplication outside. Okay, so here's my question. Simplify and use the distributive property when you absolutely need to. We're going to try at this point of the game not to go distributive happy. You can go distributive happy. Every time people learn the distributive property, they use it all the time and they forget about order of operations. Somebody asked me once, when do I forget about order of operations? Here's the answer. Never. You never, ever, ever, ever forget about order of operations. Okay, so let's do these problems. And only when you need to should you do order of operations. I'll tell you what, you try these 5, and then we'll come back and we'll make sure you got them right. Okay, we're going to attempt not to go distributive happy here. So remember order of operations. First step is parentheses. Well, there is parentheses here, so let's see if we can combine these. We have x plus 4. We cannot combine them because they're not like terms. If you're thinking, oh, yeah, just make it 4x. Well, what's the problem with doing that? The problem with making it 4x is that that means 4 times x. That's not what that says. So you cannot combine them. They are not like terms. So because you cannot combine them, this is where we have to use the distributive property because we have multiplication over terms. So this is the exact example when you have no choice. This is a 1x, so 5 times 1 is 5, so that's 5x. A positive times a positive is a positive. 5 times 4 is 20. Do not just drop that sign anymore because we deal with negatives now. So watch what I did. 5 times 1 is 5. X, the x just comes down. A positive 5 times a positive 4 is a positive 20. And that's your answer. I am done because I cannot combine these. They're not like terms. All right? Let's look at number 2. Order of operations, parentheses first. I look, cannot combine these because they are not like terms. So again, I have multiplication over terms. I'm going to distribute. So I have a negative 2. I'm going to multiply the numbers. Negative 2 times 3 is negative 6. A squared just comes down for the ride. And now watch this. Be careful. A negative times a negative is a positive 8. Notice what effect that negative had. That negative changed every sign in there. That 2 doubled every number, but that negative changed every sign. So anytime you have a negative of any kind out here, it's going to change all the signs in here. This was a positive, now it's negative. This is a negative, now it's positive. And the reason for that is because negative is opposite of. So kind of makes sense. I love math. It just all blends on together. Okay, let's look at number 3. This is a time where you can go absolutely distributive crazy. Let's think about this. Step 1. You look for parentheses. There is parentheses here. Now, I can combine these because these are like terms. So I'm going to put a 1 here. And now I have, I'm not going to let go of my parentheses because I'm not going to multiply here. I'm going to add this. I'm going to combine these. I have 1x, I have 4x's, so I have 5x. That's what I should be doing here. If you do the distributive property, you can get the right answer. However, you shouldn't be doing that. You should be following order of operations. So now, I just multiply. 5 times 5 is 25. X. So don't go distributive happy here. Let's look at this one. There's no terms here. Since there's no terms, there's no distributing. No terms. No distribute. Okay? So all I do here is multiply any 2 factors first and multiply your answer by your next one. By the way, do you know how many factors there are here? Get count. Okay, I'll tell you. There are 4. 5 times 2 times x times negative 3. Just so happen those were already multiplied. Okay? So now I'm going to multiply this. I'm going to go left to right. 10x times negative 3. A positive times a negative, signs are different, so it's negative 30x. Okay? How about this one? Well, there's actually a number in front of that parentheses. We talked about that earlier when we learned subtraction of integers. There's actually a 1 there, which makes that a negative 1. So what I'm going to do here is remember parentheses first, but I cannot do what's inside the parentheses because they're not like terms. I'm going to have to distribute. So all that's going to happen here is I'm going to change all the signs. A negative times a positive is a negative. A negative times a negative is a positive. 1 times 2 is 2. All that happens with this negative is that you change all the signs in there. And if you think about it, here's why. Because that negative, that's a fat eraser, that negative actually means opposite of. When you take the opposite of, you change all the signs of every term. So that's why that works. But a negative in the front changes every single sign. And that takes care of those problems. Okay, let's try to put together everything we learned. All right, the first problem says negative 3 plus 7 times the quantity x plus 2. Negative 3 plus 7 times the quantity, that means I have parentheses there, x plus 2. Okay, we want to simplify this. Be very careful. I know what your first step might want to be. You don't want to do that. You want to go through the order of operations. Parentheses first. Well, we do have parentheses, but I cannot combine them. So then I have to look for exponents. No exponents, so then I have to look for multiplication. I do have multiplication. The only way to multiply this is to use the distributive property because you have multiplication over terms. So watch how this looks. Do not just write the plus down. We're going to distribute the entire positive 7 to this x. Remember, there's a 1 there. Positive 7 times 1 is positive 7x. Positive 7 times a positive 2 is a positive 14. Notice what happened. What happened after I distribute, and I should have said that in the last set of problems, so I apologize. As soon as you distribute, those parentheses have to go. Because if they don't, sometimes you're going to change the entire problem. So they have to go. There's no more parentheses once you distribute, because that's a multiplication step. Now, once everything is attached by plus or minus, you just start to combine and look for like terms. Generally, the numbers go last, so I'm going to look for a variable, and here's a variable, and he has no friends, so it's just 7x. Now I can combine my numbers. I owe 3, but I have 14, so I have 11. Okay, let's do number 2. That's a bad plus. Okay. Again, we go through the steps of order of operations. Parentheses first. Well, there is a parentheses. I go inside there. There's no like terms. Can't do that. No exponents, but there is multiplication. Here it is. The only way to multiply it here is to use distributive property because I have multiplication over terms. Remember, terms are attached by plus or minus. Okay, here we go. 4 times 7 is 28x. Positive 4 times a positive 2 is a positive 8. Notice, this is where this is important. I must drop the parentheses here. Must drop the parentheses here. Plus 5x. Now, I'm looking for like terms. 28x has a friend. It's 5x, because they have the same variable factor. So I have 28x's, but now I have 5x's. That's 33x's. And 8 has no friends, so I just bring them down for the right. And I have to write plus 8. Okay? So that's number 2. Last problem, you try this last one, and then we'll check it out. Okay, 3. Okay, everybody got what they think is the first step at least? Here we go. Step 1. Order of operations, step 1, parentheses first. Well, yes, I have parentheses, but I can't use it. Second step, exponents. I do have an exponent, but there's nothing I can do. It's just an x squared. It's not a number squared, nothing I can do with it. Then I look for multiplication. I do have multiplication. I have to distribute. Okay, so I'm going to distribute the 3 to the x squared, and here we go. We have 10 plus 3x squared, and then I distribute that positive 3 to the negative 2. A positive times a negative is a negative 6. Now I look for like terms. I like to go to my variable first, so I'll go to 3x squared. Has no friends, I'll just write them down. He's a loner, no friends. Now I can combine this. I have 10, but I owe you 6. If I have 10 and I owe you 6, I have 4. So I'm done. Can I combine that? No like terms. That's awesome. Now you want to see a really awesome problem? Look at this next one in your workbook. This is so awesome. Just try that one. Just try it. See what happens. Well, this is a beauty of a problem. This is like going to be so much fun. Okay, we're gonna do order of operations. So the first thing we're going to look for is parentheses. There is an operation in here. It's actually multiplication. It's already done, so there's nothing to do there. There is an operation in here, but they're not like terms. Can't touch it. There is an operation in here. Can't touch it. Not like terms. Oh, beautiful. There is an operation in here. It's subtraction. We can do it because those are like terms. So I'm going to copy down everything until we get to that last parentheses. Minus 7, minus 6, plus 2 times y. Yeah. There isn't a problem more fun than this. I may run out of board space. I love those. Okay, so I have 7y, but I owe you 10y, so I owe you 3y. Okay, so let's take a look. Again, I can't do any other parentheses, so now I have to look for exponents. There are none. Multiplication or division. There's a whole ton of multiplication. So we're going to do the multiplication, and we're going to go left to right. Now, you're probably not going to write as many steps as I am, but I'm going to write them down anyway, because this is truly the way you should do it. Okay, so multiplication right here. This is just negative 10y. Now I'm going to rewrite. Okay, I'm going to rewrite. I'm still rewriting. Don't get sloppy and try to make a shortcut here. That would be bad. Okay. Now, left to right, I'm still doing multiplication because we don't have the parentheses, we don't have the exponent. So I'm coming here, and I'm doing these parentheses. I mean this multiplication, I'm sorry. This multiplication over these parentheses. Now be careful because you're going to distribute a -3. So we're going to distribute a -3. Since I'm distributing a negative, that means every sign inside that parentheses is going to change. Okay? So a negative times a positive, there's your negative. 3 times 4 is 12y. And then again, a negative times a negative. There's a positive, because the signs are the same. 3 times 7 is 21. And again, you really should. I know I can take some shortcuts. I'm not going to do it. Okay, we're getting down to the nitty-gritty here. We come all the way down here. We're going to distribute that positive 2. So we get negative 10y. In a minute, I'm going to have to rewrite this problem. It's getting so big. This is when it's fun. Minus 12y plus 21 minus 6. Distributing this positive 2. Do not just write that positive. You're distributing the positive 2. So this is positive 2y. Positive times a negative is a negative 2. When you distribute a positive, no signs change. I know I could sneak this in. I shouldn't really do it. I shouldn't do it. I'm not going to do it. Here we go. Now, I'm going to rewrite that. Well, I'll tell you what I'm going to rewrite that and show you how it's done here. So I'm going to rewrite that on the top and keep going. Boy, this is great, huh? All right. Again, you could have took some shortcuts. I'm not doing it. I'm just rewriting that step. Plus 21 minus 6. Let's get rid of all the smudges on the board that could look like negatives. Plus 2y minus 2. Minus a minus 3y. Whoa, I'm loving this problem. Okay, so what's the problem here? It's the rash. It's the rash because I have double signs. Sign, sign, sign. Sign, sign gives me a rash. Can't have it. So those are 2 signs. 2 signs become 1 sign, which makes sense. Okay, so here's what we got. We got negative 10y. Oh, I got to get rid of all these little things on the board because it starts looking like negatives. That will destroy our problem. Don't squish. You squish, you're in big trouble here. So this sign becomes a plus. All right, now the fun begins. We're looking for like terms here. Okay, here we go. We have negative 10y. We have negative 12y. They are like terms. Y. We have positive 2y. Like terms, like terms, like terms. Positive 3y. So we're combining this. I'm going to see if we can go right across in one step. Let's see if we can do it instead of just doing 2 at a time. Ready? We're going to do 2 at a time, but I'm not going to write it down. So I am still doing 2 at a time, but I'm not going to write it down. I owe you 10. I owe you 12. So I owe you 22. I owe you 22. All right, maybe I better write it down. I don't want you to lose me. I owe you 22y, but I have 2y, and then I have 3y. I owe you 22. I have 2y, so I owe you 20y, but I have 3y. I owe you, because this was negative 20, just make sure you know where I got it. I owe you 20. I have 3, so I owe you 17y. So the first term of our answer is negative 17y. So I'm going to put that over here. I'm going to label it answer, and I'm going to come back in a minute. Okay, now we're going to do the numbers. That's what's left. So let's take a look at the numbers. I wish I had a bigger board, you know. So this is 21 minus 6 minus 2. I think that's it. That's it. So I have 21. I owe you 6. So I have 15. I have 15, but I owe you 2. So I have 13. That's beautiful. It's negative 17y, but now I have to put a sign there. It's a positive 13. So it's negative 17y plus 13. That's a beauty of a problem. Had a great time. Okay. That ends that problem. The next thing we're going to do is add and subtract polynomials. Not polygons, polynomials. Okay.